Greenland, a vast, frozen giant at the top of our world. But now, the ice is melting, rivers carve canyons, and city-sized chunks fall into the sea. The shape of our world is changing. Greenland's story is our story. The world is watching. What will we do next? To understand Greenland's present, we must travel back in time, millions of years through cycles of hot and cold. During the Great Ice Ages, vast sheets of ice grew, covering much of the northern hemisphere. Greenland was at the heart of this expansion. Snow fell year after year, compacting into dense, blue glacial ice. Layer by layer, the Greenland ice sheet was built. This ice is a time capsule, trapping bubbles of ancient air. Scientists drilled deep, extracting ice cores to reveal what Earth's atmosphere was like hundreds of thousands of years ago. The ice tells a story of a planet that breathes, with ice sheets growing and shrinking over vast timescales. During warmer periods, the ice retreated, meltwater flowed to the sea, and Greenland's edges became green and lush. Then, as the planet cooled, the ice advanced again. This cycle of growth and retreat is the planet's natural rhythm, but today's melting is different, much faster than anything recorded in the ice. Greenland is losing staggering amounts of ice each year. The slow geological dance has become a frantic sprint. The cause, rapid warming driven by human activities. We are adding greenhouse gases to the atmosphere at an unprecedented rate. The thermostat is rising, and Greenland's ancient ice is feeling the heat. The ice sheet's story is no longer just about natural cycles. It's about how human actions are rewriting the rules of the planet. The consequences of this accelerated melting will be felt far beyond Greenland. The past is written in ice, the future is being shaped by us. The great ice builder is now in retreat. Place a heavy weight on a mattress. It sinks. The land under Greenland's ice does the same. The Earth's crust floats on a softer layer called the mantle, which can flow slowly, like thick honey. The immense weight of Greenland's ice sheet has pushed the landmass down, creating a huge basin. This is isostatic depression. The crust sinks until the upward force from the mantle balances the weight of the ice. Much of central Greenland is now below sea level. If all the ice vanished, Greenland would be a ring of coastal mountains around a vast inland sea. Now, as the ice melts and its weight decreases, the land is beginning to rise. This is isostatic rebound. The crust, freed from its burden, is slowly bobbing back up, like a ship being unloaded. The rebound isn't uniform. The edges, where ice has melted fastest, are rising more quickly than the center. This uneven lifting is tilting and warping the landmass. The ground itself is deforming, reshaping Greenland in real time. We are witnessing a continent in motion, a landmass reshaping itself before our eyes. This transformation is happening on a human timescale, not just a geological one. The story of Greenland is not just about melting ice, but about the living, moving Earth beneath it. The land's response to the loss of ice is a profound reminder of our planet's interconnected systems. Greenland's rising land is a signal, a warning, of the changes underway. The ground is telling us, nothing here is permanent. The future of Greenland is being written in rock as well as ice. The awakening giant is not just melting, it's moving. The land's rise and fall is like the slow breath of a planet, too gradual to see, unless you know where to look. When ice ages came, the weight of ice sheets pushed the crust down. When the ice melted, the land began to spring back up. This rebound is still happening in places like Scotland and Scandinavia, long after the last ice age. The Earth has a long memory. The mantle beneath the crust flows like thick syrup, always seeking balance. In Greenland, this process is now on fast forward. The ice is melting over decades, not millennia, causing the land to rebound at a startling rate. Some coastal areas are rising by as much as an inch per year, a geological sprint. New islands are appearing, harbors are becoming shallower, and maps are being redrawn. The slow breath of the planet has become a sudden gasp. Greenland is the epicenter of this dramatic geological event. The land's movement is a direct response to our changing climate. The world is watching as Greenland redraws its own map. The planet's slow breath is now a race against time. How do we know the land is moving? We listen. With technology, scientists have placed a network of highly sensitive GPS stations across Greenland, bolted into the bedrock. These instruments measure their position to within a fraction of an inch, tracking the land's movement day after day. The GPS network acts like a planetary nervous system, sending a constant stream of data to scientists. By analyzing this data, researchers map how the land is rising, sinking, and even tilting. The bedrock's movement changes with the seasons, rising faster in summer as ice melts, slowing in winter as snow accumulates. The land is breathing in time with the annual cycle of melt and accumulation. This discovery shows how sensitive the Earth's crust is, a dynamic system, not a static shell. The GPS data provides an independent way to weigh the ice sheet. By measuring how much the land rises, scientists can calculate how much ice has been lost. The rocks themselves are acting as a giant scale, measuring the pulse of a changing planet. Greenland's bedrock is telling us a story, one of loss, movement, and transformation. The land is speaking, and we are finally learning to listen. The movement isn't just up and down. The GPS data reveals a more complex motion. As the ice melts, the entire region is being deformed, not just the land beneath the ice. Think of a soft rubber sheet, push down in the middle, the edges bulge, lift your finger. The bulge collapses inward. As mantle material flows back under Greenland, the surrounding crust is pulled horizontally toward the center. The landmass is rising and being squeezed from the sides, reshaping the entire tectonic plate. This deformation can affect geological faults, potentially triggering more small earthquakes. The planet is adjusting to a new distribution of weight, sometimes in sudden jolts. Greenland is showing us that the mantle can flow much faster than we thought. The Earth's interior is more dynamic, less like cold honey, more like warm caramel. This forces scientists to rethink how the deep Earth interacts with the surface. Greenland's shifting crust is rewriting our understanding of the planet itself. For centuries, Greenland's waters have challenged even the most experienced mariners. Now, as the land rises and ice retreats, the environment is becoming even more unpredictable. Harbors and fjords are growing shallower. New rocks and shoals are emerging as hazards. Traditional knowledge and old maps are quickly becoming outdated. At the same time, melting ice is opening new possibilities, like the Northwest Passage, now ice-free for longer each summer. New shipping lanes could dramatically shorten travel times between continents, attracting global interest. Navigating this new world will require constantly updated high-tech maps and surveys. Satellites and sonar-equipped ships will be essential to keep up with the changing sea floor. The Arctic is becoming a dynamic frontier, one where adaptation is key. Greenland's shifting land and sea are reshaping the future of navigation. What if Greenland lost all its ice? Sea levels would rise by over 20 feet, a global catastrophe. Coastal cities worldwide would be inundated, displacing hundreds of millions. Greenland itself would become an archipelago, a ring of mountains around a central sea. As the land rebounds, new ecosystems would emerge, plants and forests where ice once stood. But the changes wouldn't stop there. The influx of cold, fresh meltwater is already disrupting ocean currents, threatening to alter weather patterns worldwide. A slowdown of the Great Ocean Conveyor Belt could bring dramatic, unpredictable shifts, cooling Europe even as the planet warms. For Arctic peoples and wildlife, the changes are already real. Traditional ways of life are under threat, and animals are losing their icy habitats. As new shipping routes and resources open, Greenland faces new economic and political pressures. The future is a complex tapestry of risk and opportunity. The choices we make now will shape this unfrozen world. Greenland's transformation is a warning and a test of our wisdom. The story is still being written. Greenland's shifting land is more than a local story. It's about our place in the cosmos. The same laws that shape stars and planets govern the flow of ice and rock on Earth. By studying Greenland, we learn how planets work and how our actions can reshape them. The GPS network is like a telescope, but pointed inward, revealing the hidden mechanics of our world. This knowledge belongs to all of us, not just scientists. The changes in Greenland are a lesson in cause and effect. Our actions are now a geological force. The future of Greenland's ice and our coastlines depends on choices we make today. We are explorers, driven to understand our world as much as the stars. Greenland's story is a chapter in the grand story of cosmic evolution. It's a story of change, adaptation, and the dance of forces that shape worlds. As the ancient giant awakens, we're reminded of our planet's fragility and power. We are all crew members on Spaceship Earth. The responsibility to navigate its future is ours.